Physicists, we're going to do another problem here. This is page 99, number 3. It says a pelican flying along a horizontal path drops a fish from a height of 5.4 meters. The fish travels 8 meters, 8 meters horizontally before it hits the water below. What is the pelican's speed? So just like all these other problems that we've done, we're going to start by drawing a picture. So I'm going to draw my pelican. Don't judge. You draw your pelican. I draw mine. This is what a pelican looks like in my head. And then we'll go ahead and put a fish up there in its mouth. And I guess that pelican probably needs a tail and a wing. All right. And it's flying, let's say it's flying over water. Oh, yep, it says water. Okay. And so we know that it is starting a distance 5.4 meters above the water. And the fish, so the pelican is moving. This one's a little bit different. So the pelican is flying and it's going to keep going in this direction. And the fish, as a result, is going to follow a trajectory that looks like that before splashing into the water down over here. Okay. And my trajectory got a little messed up there. And it says that it's going to travel a distance of 8 meters horizontally before it hits the water. So hopefully that kind of gives you an image of what's going on. So the pelican is just going to keep flying horizontally and the fish will fall. And to the pelican, the fish looks like it's going to fall straight down. But because the pelican is moving, the fish actually is following a projectile path from a perspective out away from the pelican itself. Just like every other setup, we're going to start with our givens. We're going to start with our givens chart. So we've got delta x, Vx, and Ax. And same in the y direction, delta y, Vy, Ay, and the thing that holds it all together is, of course, t. Just like every other problem, we're going to start off by putting our accelerations in because we know that they are the same every time. The acceleration in the x direction is 0, and the acceleration in the y direction is negative 9.8. It looks like we have two other givens that are certain here in terms of the distances or displacements, The displacement in the x direction is that 8 meters. That's the range, that's how far it's gone in the horizontal direction. And the displacement in the y direction is going to be negative because it's falling down 5.4 meters. It has an initial velocity that is only in the x direction, in that direction. So that means that the velocity in the y direction is 0 meters per second squared. We want to know what the pelican's speed is, so we're solving for Vx. And we can do that by first finding time. It's that same equation. Delta y is equal to Vy t plus 1/2 Ay t squared. The Vy is 0. Solving for t, we get t is equal to the square root of 2 delta y over Ay. If that's confusing to you, check out the videos beforehand. Go through the algebra yourself. Make sure it makes sense to you. Don't just rely on me saying it, but double check it for yourself. I'm going to go ahead and plug in my number. So I've got 2 times negative 5.4 meters, a little lower than the ones that we've been doing before, and then divided by negative 9.8 meters per second squared. I'm going to plug that into my calculator. You do the same. So I've got 2 times 5.4, negative 5.4. I'm going to divide that by negative 9.8, and then take the square root. And I think I get 1.02. True confessions, I'm doing this on my phone calculator, so I'm not positive I did that right. So double check yourself, make sure that that's what you get as well. Okay, I get 1.02 seconds. Now we need to find the velocity in the x direction, and honestly, regardless of if the number's right, we can still do some physics to make sure it makes sense. So we've got delta x is equal to Vxt plus 1/2 Axt squared. The acceleration in the x direction is 0, and therefore we can say that Vx is equal to delta x over t. We can plug in some numbers there, saying that we've got 8 meters divided by, hopefully that's that 1.02 seconds, and then we can, see, we're going to do, so 8 divided by 1.202, And assuming that my time was right, I'm getting a value for that initial velocity of 7.8 meters per second. There you go.